Welcome to Nature Walk, the podcast where we delve into the wonders of the natural world and explore the intricate relationships between species and their environments. I'm your host, David, and I'm thrilled to share with you today's fascinating story from the Caribbean coral reefs. Imagine yourself scuba diving in the crystal clear waters of the Dominican Republic or Panama, surrounded by a vibrant array of fish and coral. But beneath the surface of this breathtaking ecosystem, a subtle yet significant shift has taken place. Researchers have discovered that modern food chains on these coral reefs are roughly 60 to 70% shorter than they were around 7,000 years ago. To understand the implications of this finding, let's dive into the world of fish ear stones, or otoliths. These tiny calcium carbonate structures play a crucial role in helping vertebrates move and hear. By analyzing the shape and composition of otoliths from fossilized and modern fish, scientists can reconstruct the food webs of the past. It's a bit like being a detective, searching for clues to unravel the mysteries of the ocean. The team of researchers, led by Jessica Lueders-Dumont, found that ancient reef fish had highly specialized diets, with each species occupying a unique niche in the ecosystem. For example, a goby might feed exclusively on a particular type of amphipod, which lived on a specific coral. This diversity of dietary specializations contributed to the complexity and resilience of the food web. However, as we fast forward to the present day, we see that many modern reef fish are competing for similar food sources. The loss of habitat and overfishing have pushed species to adapt and reposition themselves within the ecosystem. It's a bit like a neighborhood where locally owned restaurants have been replaced by national chains, offering similar menus. If one restaurant struggles, the entire community feels the impact. But there is hope on the horizon. In Panama, where fishing regulations are strictly enforced, researchers have found pockets of pristine coral reefs with healthier food webs. This suggests that local management and conservation efforts can make a tangible difference in preserving the delicate balance of these ecosystems. As we explore the natural world, we're reminded that our actions have consequences. The story of the Caribbean coral reefs serves as a powerful reminder of the importance of responsible stewardship and conservation. By understanding the intricate relationships within ecosystems, we can work towards creating a more sustainable future for all species. We'll be right back with more fascinating stories from the natural world on Nature Walk. Welcome back to Nature Walk. I'm your host, David. As we continue our journey through the natural world, we find ourselves in the midst of a crisis that's unfolding in Patagonia. This sparsely populated region at the tip of South America is home to some of the most ancient and majestic trees on Earth. The Alerce trees of Los Alerces National Park in Argentine Patagonia are a testament to nature's endurance, with some specimens estimated to be over 2,600 years old. These natural giants have seen civilizations rise and fall and have been silently standing guard over the landscape for millennia. But now, these ancient trees are under threat from severe wildfires that have been sweeping through the region. The fires, fueled by excessive heat, drought, and fierce winds driven by human activity, have already killed 23 people, forced tens of thousands to evacuate, and scorched dense native forests and national parks. As the blazes continue to burn, they're not only destroying the trees themselves, but also releasing massive amounts of carbon dioxide into the atmosphere, fueling global warming and creating a devastating feedback loop. The loss of these ancient trees is a tragedy that goes beyond the immediate destruction of habitat and biodiversity. It's a blow to our collective efforts to mitigate climate change, as these trees have been drawing carbon dioxide out of the atmosphere for centuries. The largest 1% of trees, like the Alerce, store roughly half of the above-ground biomass carbon across forest biomes, making them a crucial line of defense against rising global temperatures. As we consider the fate of these natural wonders, we're reminded that the consequences of climate change are far-reaching and interconnected. The destruction of old-growth forests like Los Alerces not only imperils vulnerable species, but also reduces the Earth's ability to store carbon, exacerbating the problem. It's a stark reminder that our actions have real-world consequences, and that the natural world is intimately linked to our own well-being. As we reflect on the plight of Patagonia's ancient trees, we're compelled to ask, what can we do to prevent such tragedies in the future? How can we work together to protect these natural treasures and preserve the delicate balance of our ecosystem? These are questions that we'll continue to explore on Nature Walk as we delve into the complexities of the natural world and our place within it. Welcome back to Nature Walk. I'm your host, David. As we conclude our journey through the natural world today, let's venture into a realm that may seem far removed from the trees, birds, and wildlife we often discuss, but is nonetheless integral to our understanding of the universe, the world of subatomic particles. A recent breakthrough in measuring the size of a proton has significant implications for one of the core theories of physics, known as the Standard Model of Particle Physics. This theory describes how subatomic particles interact with each other and has been incredibly successful in predicting various phenomena observed in experiments. However, for over a decade, scientists have been puzzled by conflicting measurements of the proton's radius, which is crucial for testing certain predictions made by the Standard Model with high precision. The proton, a positively charged particle found in the nucleus of an atom, is so small that its size is measured in trillionths of a millimeter. Recent research published in Nature has provided a precise measurement of the proton's radius, using hydrogen atoms and measuring the frequency of radiation needed to make these atoms jump between different energy levels. This precision is not just about academic accuracy, it has significant implications for our understanding of the physical world. By confirming that the proton's radius is smaller than once thought, scientists can now use this data to test aspects of the Standard Model with greater confidence. Specifically, this confirmation allows for the testing of quantum electrodynamics, a part of the Standard Model that describes how electrically charged particles interact with light. The process involved studying not just regular hydrogen, but also an exotic form called muonic hydrogen, where a proton is bound to a heavy cousin of the electron known as a muon. The match between the Standard Model's predictions and the experimental results vindicates this theory, at least within the context of this experiment. It's fascinating to consider that while the Standard Model is incredibly powerful, it doesn't explain everything, such as dark matter, which plays a crucial role in the structure of galaxies. Scientists continue to test its limits, knowing that our current understanding of the world is not complete. As we explore the intricacies of subatomic particles and their interactions, we're reminded of the vast scales at play in the universe, from the smallest particles to the expansive cosmos. Each discovery, no matter how small it may seem, contributes to a broader tapestry of knowledge that helps us understand our place within this grand scheme. That's all for today's Nature Walk. Remember to like, share, and subscribe, and until next time, keep exploring your natural world.